Hello folks, it is Advent of Code day number 24. Come on, let's do this. I just finished doing a really quick, finishing a thing that I had been poking at all day long. And it only took me about, let's say probably 9 hours of eight concerted hours of work to get a reasonably production grade continuous profiling cluster up, so that was exciting. But we're here today to do day 24. So let's do this. 14, 24, yes, and math. Put strconv back. So that's why my stream is a little late today, and I should tweet about it as well. Penultimate day of Advent of Code. Alright, I have tweeted. Now we just need to clean this up, and we should be basically in fine shape to start our day. Alright, there we go. Just in the nick of time. As you may see here, I did not actually solve day 23 successfully. I know what I need to do to get my solution to run fast enough, but that will have to be a stream tomorrow because I am a little bit too tired to be refactoring code that is that hairy. Although, who knows? Maybe this one will be a quickie and I can get that done really fast after we finish day 24. But for now, let's go ahead and take care of day number 24. Onwards, folks. Onwards, onwards. All right. ALUs. Okay. Yeah. This is the old classic. This is the old classic. Build a register and build a computer. Love it. I love these puzzles. One of the previous Advent Code years was centered around this, which people found to be a little bit much, but. Thank you, Eric, for bringing back the for bringing back the computer. So let's do it. So my puzzle input. I appreciate the heck out of this, Eric. This is a wonderful way to almost end the year. You're going to make me a very happy person here. Okay. I probably have enough oxygen. This feels very Apollo 13-ish. Okay. 4-dimensional. Yep. WXYZ. Yep. Immediates can only occur in the second operand. No jump operations. Run from start to beginning. Should never divide by 0. Yep. Okay. So we need to check 14-digit numbers. And find the largest valid 14-digit model number that contains no zeros. That's got a lot of possibilities. I guess if we're being asked for the largest, we can, to some degree, binary search this. All right, let's write a machine and see what it does. So we know that we're going to need a type instruction struct. Actually, wait, this is no flow control. No flow control. What does INP do? It'll leave some number in Z. Where does Z get written to? Interesting. Interesting. Okay, so Z is essentially kind of like an accumulator, which I think means I think I can probably treat each of these sections separately and find out. Thing is, this already takes the existing values of x and z. That's kind of a problem. Okay. Well, let's try to solve it naively. It just might work, and then we'll go from there. So yeah, no flow control, which means okay. So how do we do this? So in this case, I know that my program has exactly 14 inputs. All right, and I also will have some list of instructions. And then I'll have some kind of registers, which are going to be 4 registers. Yeah, 4 registers. Okay. So a instruction will take as an input a computer. Oh, and of course we've got the current instruction pointer. What's it called on most systems? The program counter. Okay. So that'll do. And let's go from there. And also I will send a screenshot of a thing that I was meaning to send to. Okay. Cool. Now let's see. So now I need and for now, I'm going to mutate the computer in place. This may or may not work forever, but that's okay. Oh, yeah. This just needs to be the type specification. All right, so instrs PC and we pass ourselves in. PC is equal to length of C instrs. Return true. Okay. So now essentially what I'm going to have here is is just this. And then the output of this is going to be Z. So we're just going to W, X, Y, Z. Okay. All right, so now computer Z. So we'll have something like that at the end. Now let's go ahead and go back to the beginning and have a look at the parsing, because that's going to be important. Oh, and we'll have an input count as well. Okay. Nope, I don't actually need this. Okay, parts is split S space. All right, so now we've got 6 valid operations, which are 6 of these. So we've got input, add, mul, div, mod, and equal. Okay. Computer dot instructions. Okay, something like that will work. Wow, I am starting to fade fast. Doing a lot of hacking today has definitely made me a little bit more tired than usual, but that's okay. That's okay. We'll just roll with it. We'll just roll with it. Let's see. What do we have here? So if it's input, then what we do is C registers W equals C inputs C input C input C plus plus. Okay. So now I've got to do operand parsing. Oh wait, This always happens to input to W right now, but it could input anything. Okay. So this is going to be a byte. So it's always going to be W, X, Y, or Z. So I think that should do it. So I think that'll work. Okay. Now, in the case of an add, still of something very similar to this. Oh, and of course this always does... Actually, no, we're incrementing the PC here. We don't have to handle that in this step. Wonderful. Okay. Okay. See this. So, probably the best way to handle this is to just attempt immediate error is strconv a to I of parts 2. If error is not equal to nil, then instead we know okay, so this is what we have here. No, this is not instruction, this is register. Okay, how do I define an iota that starts at -1? Forget how to do this. Oh, type register int. Does this work? So if I want to skip a value, it always increments, but it can do something else. Let's read Rob Pike's blog post. That was not actually what I was expecting to see. Okay, you know what? I'm just gonna go with it. Okay, So now if source is not equal to ndef, then like that. Oh, but it's not just that. It's add the value of A to B and then add. Okay. So this is just plus equals. Great. All right, add mole div and mod, and finally equal. Store 1, otherwise store 0. All right. Cool. I think that'll do it. Let's just run it on a very simple input. So I'm just going to pass in, I think that's 14 ones. Double check this. Yeah, that's 30 characters. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep, went over by 1. Okay. Okay. So let's just do this for now and make sure that this works. So we'll initialize this initially, and then my comps inputs equals v. Okay, so oh right, that doesn't need a function body. Go like this instead? No. I did an iota yesterday. Oh, equals iota. Okay, so now that makes sense. Oh, now that worked nicely. Let's just run it. Oh, yeah, I didn't use my attribute. That's okay. Line 67. Oh, strings split. And line 138. I called that regs. Yep. Line 138. Does iota not start at 0? Oh, right, because this had to start at -1. So in fact, I can define this like so. Okay, now we're in better shape. Which line errored? Line 70. Oh, yes. What did I do? Greater than 2? Yeah, that'll work. Ah! Wrong button. Why do we even have that button? Etc. Okay. Immediate declared but not used. Oh, that's because I'm shadowing it. Okay. Now on line 81. How could target get to be a ridiculous number here? Oh. Let's just check this. Let's just figure out what's going on here. W is out of range. Oh, because I'm subtracting X. W comes before X in the alphabet. Duh. Why does my keyboard sound slushy tonight? I'm not sure. Literally no idea. Okay, that ran reasonably quickly. So, I have no idea whether the program works, but I guess what I can do is I can... I'm going to probably trust that this works. How long is a 14-digit decimal number? Yeah, okay. These guys are huge. This is 44 bits long. That is what I needed to know. Okay. But at any rate, I can convert this to just a uint64, and then we can handle the decimal decomposition. We'll do it this way. Or not I. Okay, let's just check this. And make sure that that looks reasonable. So I'm going to feed in this number and see what it says. Oh, that's fine. Does that work, or do I need to? Okay. Ooh, it's going to be nasty. Okay, 135764. Yep. Okay, that's good. The largest valid number that contains no 0 digits. So let's start with the highest of these. So let's start this way, and then we'll partition a search space is what we'll do. Okay. So I can't do a strict binary search, but I'm very curious, like, what one successful one of these would look like. Okay. For now, I'm just trying to loosely approximate this. If success and highest success is less than success, then for now, I'm just going to break out of the loop here when I have one success. So I want to just experiment here. Success. So I'm basically trying to roughly approximate some kind of binary search. Something like that should do the trick. Oh, right. That. Okay, that's exciting. Oh. Righto. It's causing us to shoot off the end of this. This should make a brand new copy of my computer. Oh, because I ran computer.step, not my comp. Okay, let's make sure that I got that right. Yep, I think I did. Okay, so now it resets to 0 at the beginning of every day, of every one. We could be searching a while. Okay, now it's time to maybe disassemble this. Okay, so we talked earlier about the fact that it spits digits into Z, and that Z can only go up. Unless Yankee gets set to 0. Okay. Maybe this is supposed to not be worked programmatically. Yeah, I think that's why it was strongly hinted to approach this one step at a time. Because the highest digit is always going to be the thing that influences whether or not you can be successful. So, okay. So now I've written a machine that does this, but I'm not fully satisfied with this algorithm here. But I'm just going to commit this for now. Oh no, what did I edit here? Oh, it's fine. That's going up to GitHub, and then now I'm going to work in a hand disassembly instead. Okay, so let's see this. Oh, did I get the initial values? All variables start with the value 0. Great. So x gets multiplied by 0, but it was already 0. X and Zulu get added together, but X is already 0. Zulu is already 0. X gets taken... Yep. 0 mod 26 is still 0. Z is divided by 1, that's still 0. Okay, so now here, x is 11. Okay, if x and w are equal, but w is never going to be fed the number 11. So that's always going to be x is 0 here. X is 0, so now x gets set to 1 here. Y gets multiplied by 0, but we know that y is still 0 here. So after this, y is 25. X times y, so y gets set to 25 here, because x is still 1. Here, y is 26. Z is still 0, so that doesn't change anything. Z is still 0. Y goes to 0 here. Okay. So this is just y equals w. Y equals w plus 6. Y equals, x was set to 1 earlier, as far as I know. So that just means y equals w plus 6 still. Finally, z here equals w plus 6. Okay, so that's the first block. So now in the second block, what do we have? Did Eric design this just to like force everyone to like manually work this out? Surely there's got to be a better way than manual, right? Okay. There's no subtract function, so yeah, unless I'm getting this wrong. So x goes back to 0 here, after being set to 1. So at this point, x is w of 0 plus 6. Now, x gets modular by so now this is this. Eric will talk about puzzle design after there are no points left to get for this puzzle. Whoa. Okay. We are 40 minutes in. Only 16 people have actually solved. Eric is ending this year on a with a bang. I expected like an easier puzzle at some point, but at this rate, I'm going to be working on these after Christmas, which is fine. I like doing Advent of Code, but I don't think that I'm going to be able to both finish my day 23 solution and do day 24. You know, I basically got what, like, you know, 8-ish good hours in me tomorrow, and then there's going to be whatever day 25A is, and I'm not going to be able to complete day 25B. Like, basically, this is going to spill into this weekend. I've now resigned myself to accepting this. Okay, well, let's proceed onwards. Good lord, there are going to be 14 of these segments. I understand now why Eric was chuckling when I was like, oh, Eric gave us a nice, easy, you know, evaluate the assembly puzzle. But no, it is not that. That is hilarious. Okay. Good news is once people get Part A, they tend to get Part B pretty fast. But I think given that we are in for a rough ride tonight, yeah. Let's go back to day 23. I would rather finish day 23 right now. I will wait until more people have solved day 24. I may need to ask for a hint. Let's go back and solve day 23. I have more confidence that I can do that tonight, whereas I have zero confidence that I am going to solve day 24 like without at least, let's say, 5, 6 uninterrupted hours probably. So yeah, let's do this. So what we're going to do here is we're going to just change this. I'm going to update my title so it is not misleading. Okay. I have peaked at 24. I've decided it is, at the moment, not to my taste. Because I am tired. My brain is not fully thinking straight. I do have all of day 23 paged into my head, and it's been rolling around my head all day. What we're gonna do. Function comments in Go go outside the function braces. We recursively use allowed movements. Okay. All right. So that way I don't have to throw out any of my old code. It's technically slightly less efficient, but the main thing that this does is that it shrinks my search space and the amount of memory they need roughly by an order of magnitude because I'm no longer searching intermediate states and storing them. Okay. We'll avoid visiting ourselves. Okay. And with these guys, if there were space available, technically, yeah, I can't just use Manhattan distance. I have to, okay. Okay. Yep. No, this is wrong. Why's my brain doing this to me? Okay. All right. Okay, that's right. And we will increase our cost by get cost. It's called movement cost. Great. That's just movement cost singular. Okay. Yeah, this is going to take a while. Yeah, I am glad I am doing the thing that is giving me the more fun right now. Okay. So, by the way, I should explain what happened and why I am still stuck on part B of 23. My solution ran out of RAM. Like, I oomed my computer. It was not fun. I'm especially glad I didn't do it while I was streaming. But yeah, I left it to run, and leaving it to run was not sufficient to solve this. So, all right. Okay, so I need a can't stop here. Oh, and this is also... So let's define this. Okay, so... I have to say, Eric, this is really N characteristic compared to like previous years where you've made like day 24 like relative on the easier side. At least one out of days 21, 22, 23, 24 has been on the easier side to not discourage people. I sincerely, with much love and respect, Eric, I think putting one of these difficult ones earlier would have, and putting an easier one in this last week would have helped some people feel like there is a reason to keep on going with them, as opposed to Eric has set the difficulty meter too high, but who knows. It is not valid to stop me. Wait. Is peace with forced movement even correct? Let's work. Oh, I see. Okay, so I technically have written this logic twice, but I don't really care that much. Okay. Eric says, putting an ultra hard early puzzle, try to get more people, okay, just to see how it went. Yep, science. Yeah, I agree to science. Cool. Well, I look forward to solving all of these eventually, you know, maybe hopefully in the month of December, but if not, I'm going to have some time on my hands, going to have my time on my hands while I'm cooling my heels in quarantine in Sydney. At this point, it's going to be quarantining to keep me safe from Sydney rather than Sydney safe from me. has reached destination. Okay. Great. Now just a couple of syntax errors. First of all, this, and then line 212. Oh. Oh, and I need to set visited, of course. Okay, append is not used. Oh, yep, that's bad. Very good. Thank you, Go Compiler, for saving me from myself. You know what? This check is done elsewhere. It's fine. Oh, but I guess I do want to save the effort of computing. Oh, but the movement cost is tiny. Yeah, okay. This makes it more readable. Okay, line 308. So all right. It's going to be J. That hall pass logic I think I can get rid of because now I'm only moving things to valid locations. But I'm just going to leave it there to be safe for now. And this is actually... Okay. All right, 308 is wrong. Oh, yes, of course. All right. Let's see whether we get a correct answer. Oh, whoa, now it can't find any paths, and it returned rather quickly. That's bad. What's happening here that's causing this? No, I'm going back to day 23B because day 24 it seems like it's going to take some sleeping on and thinking about, so I'm not bothering to do that right now. I know I'm going to need to sleep on it for the night, so I may as well sleep on it offline. So instead, we're just finishing day 23 because, yeah, I almost have a working solution. I just need to... yeah. So... Oh. Right, this is immediately returning because I have put A into the visited set. Okay. There we go. That was a problem. Now this should actually run for a non-zero amount of time. And that actually finished reasonably quickly. Surprise, surprise. And 526. Yep, that's correct there. Great. So, oh, that returned immediately. That is not correct. It is too low. Okay. Well, now I'm at least able to iterate. So there is... Yeah, I wanted to pop open my process map, and I was like, wait, it's done already? That was fast. Am I allowing an illegal move? Is that what's going on? Ooh, okay. Well, that was relatively straightforward. Yeah. Yeah, that is definitely, that is a problem. Let's try fixing that. What was my wrong answer here? 37,322. Let's see whether I'm consistently getting the same bad answer. But my this should never happen at least is not being set off now, which is good. Yeah, okay, I'm still getting an answer that is too low. It is easier to debug an answer that is too low than too high in this particular case. Well, I guess they're both interesting, right? Like, an answer that is too low in a situation that is following A star means that you are allowing an illegal move, or you're computing the cost of a move as too low. So this is fascinating. It's interesting that I got the correct answer on part A, but not on part B. Oh. I think I understand the problem here. Yes, I am allowing an invalid movement. Specifically, world has a list of 16 amphipods. How am I verifying that I'm not walking through myself? Okay, but I guess I'm just searching all of the neighbors of myself, so I should never wind up needing to walk through myself unless I'm moving more than one space at a time. That's my problem. Okay. Yes, this passable function is now wrong because I am... No, but if you're moving more than one square, it should be... If you're moving more than one square and you're not backtracking, that should be actually be okay. Interesting. This feels like this should be fine. Because I'm making a one-step movement. I am making a one-step movement. Yeah, I think there is an edge case here where I need to update the world that I'm working with. A question from DJ is, can you land a S3 jobs being a recent new grad? Yes, but only at a large company. In general, it is hard to become an SRE at a company that is small because they need you to already know what you're doing. Whereas in a larger company, you won't be like one of one or two people doing DevOps. You'll be like part of a team of, 10 people with more experienced people around you. So definitely check out bigger companies. Like, I don't mean like, Facebook, Apple, Amazon, etc. Like, you can do that, but like also there are like mid-scale companies like Twilio, companies like hesitate to recommend some of these because of like labor issues, but like there are some of the like unicorn type companies out there that will definitely be good for you. Okay. Did I call them pieces? Yeah, I did. I'm either violating this constraint or I'm violating the hallway pass constraint. Could this potentially... cause me to incorrectly set the hallway pass? It's the only thing that's coming to mind here. Okay, I know I'm close. I know I'm really, really close here. Especially because I got the correct answer on part A, right? That's what boggles the mind. Oh, wait a second. I'm not going to change this. I now want to go back and check to make sure that my extension of the board for part B actually put the pieces in the correct order. So it's possible that I'm solving the wrong puzzle now. I think that is equally likely. Okay. Okay, so now I verified that condition is fine. In fact, I can check this. I can check this against this simple case now that it runs in a reasonable amount of time. So that's what I'm going to do. So that's this example, BC, BD, ADCA, and it's appending in DCBA, DBAC. Did I answer your question, DJ? I hope I did. Yep, that's 12,521 as well. Interesting. So whatever bad case that I have, oh wow, I'm not even using that much memory. Let's switch it to CPU consumption. Okay, it's still going. Is still thinking. The other possibility here is that my termination condition is wrong. And that I'm prematurely declaring victory when I should not be. But figure out which of those two things it is. Huh. That's fascinating that I return much more quickly on my real output than on the part 2. Or sorry, than on the part 2 example. Yeah, that really suggests that I am tickling a bug where I'm declaring that I'm done when I'm not. Yep, it just finished. And it says 4,100 or 41,349. Aha. Okay, we get a different answer. Okay. So yes, that is awfully suggestive of... What is it suggestive of? So now that I know this, and now that I know that it returns a result, I can now print out each move, the position at each move, and backtrack it, and that'll tell me where my invalid move is for sure. Or it'll, yeah, okay. So we're going to do this. Oh, that's not source. That's actually going to be current. Okay. So now we have an answer that we can backtrack. No, that's going to need to be a... Yeah, because I can't guarantee that those will have the same memory address. Okay, so that makes that work. I'm sure this will be jumping out to me as soon as I look at the move costs and I look at the and I look at the board permutations that have happened. G-score of... No. Now let's just write our print board function, and then everything should be clear now. Okay, so what's the total height of this board? Total height of this board is 1, 2, 3, 4, 5, 6, 6. 1, 2, 3, 4, 5, 6. Yep, that's correct. This one we talked about. This one is at position 9, 10, 11, 12. Can I just pass an empty map here? No, because I have to return something that always returns true. Did I define terrain yet? It's just a... Okay. That's just going to be a type. You know what? Let's just pass a real terrain. match as closely as we can. How do I render this as a car? No, I just want to print this as a I know that this is just a car. The uninterpreted bytes of the string or slice. I guess we'll try this. This is going to be just a plus content step type, I think. Oh, -1. And then I need a print line after. Okay, let's try that. 489 is wrong. Oh, yep. Okay. Almost there. And right. Ooh, that's bad. That's not what I expected. Does that work? No, I can't add a rune in an int. Try byte. Am I allowed to do byte arithmetic? Let's find out. Nope. Still don't like that. Fine. Bytes and strings are interchangeable, right? Cool. Oh, move cost %d. Let's say print f. Okay. Alright, so we wrote some nice debugging functions today. It's exciting. Actually, let's run on my real input, because I know that that returns relatively quickly, and it might illuminate my problem a little faster. Even if I don't have the example to compare against, I think it'll be really helpful. Okay, so I start with, just check my input, my previous day of input, so I should start with C, B, A, D, B, D, C. I'm inserting a string. Folded up piece of paper inserts DCVA, DBAC. Okay. Okay, so they're saying that it costs 9 to move from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I believe that. That costs 5,000 to move. Yeah, that's correct. Let me actually print this. Print the final value as well. All right, so 2,000 to move 2 spaces, 9 to move there, 8 to move. You know what? It's really distracting that it's. I need. That needs to be. Like this. Or no. The problem is actually here. Now I think I've got a good handle on this. All right. So over here, my simple input, I get 10, 5, 26 doing that. I'm going to trust that all of these moves are valid because otherwise I wouldn't be getting the wrong answer. So now we have this guy here. Okay. So from here, we're fully sorted. And it costs 20 to move there. Yep, I believe that. Oh, wait, that's not right either. Here. This is going to print the final state here. Okay. And then this needs to print the, not the previous. Here, this one actually needs to print the source. Wait. No, that one's fine. This one needs to print current. Okay. Now that's going to look correct. All right. Let's debug the steps, figure out what I did wrong. And then that will illuminate either which move is wrong, or will illuminate that Eric did some is not accepting a valid answer, although I suspect that I did something wrong. Because Eric is very rarely wrong. Okay, so let's start from the sorted state. Move a piece 2. Yep, move a B2, that works. Move a B3 and do that. Yep, that's fine. Move an A3. Yep. Move a O. Oh, okay, that's the illegal move here. Is that I'm not allowed to pass the B. Let's see. This B was here. And instead of moving all the way down into the burrow, it stopped midway. Now, this doesn't affect the cost here, I don't think. Yeah, because I moved the B out of the way first before moving the A. Whereas that B had to go all the way into the burrow. It could not stop. So that's my problem. Okay. Yeah. Thank you, A9, for beta testing. And yes, Eric, you were right. My solution is turning up an invalid possibility. So, I'll fix. I fix. So it is true at that particular moment that I had the hall pass, but even if I hold the hall pass, if I'm starting from a position Ah, there's my problem. Okay. I see the logic. Okay, so... I'm going to do this. Yeah. What calls can stop here? Okay, no, only those two things. Okay, great. And only if I have once I okay. That was my problem. All right. I'm going to hide this behind the debug flag because goodness knows I need the debug flag today. Okay, this is fun. Debug false. Whether to print debug output. Okay, all right, that should do it. So, Tina is wrong. Oh, this is great. So that still yields 10, 5, 26, but now I'm going to have 41, 284, which I think is higher than the previous proposed solution. That's correct. Boom. Got it. Hell yeah. Okay. Let's just run it without the debug flag and make sure that that works. Knew I could do day 23. Yeah, that's plenty fast. And let's look at the profiles now. I'm really curious. Go. Oh, that didn't save. Let's see what that looks like. Oh, that is very satisfying. So much less time spent in the heap. Spending a lot of time doing passable ore contents. That's kind of hard to help myself from needing to do. I guess the way that I can handle this is on each world rebuild, I can rebuild some of the mutable state, and then I don't have, that doesn't stick in the map. Cool. Yeah, that is a solution I'm actually moderately happy with. I'm pretty proud of this. That I was able to take a day 23 that really didn't work. The law that I broke was that you have to go directly to your burrow. You cannot stop even on another non-doorway tile once you're in row 1. So, here, let me show you the diff of what I needed to do. So I wrote some functions to print the board state. I close all these tabs I no longer need. I wrote something to deal with generating intermediate. I made the previous layer of move generation a intermediate layer, and then I made a real move generation layer, which uses this to keep track of the cumulative distance traveled. I created a function that says, am I allowed to stop here given a given starting place? So I was missing this. This is what I messed up. And then otherwise we're fine. And then this was the main new code that I wrote today. Was just populating a list of finished movements rather than intermediate movements. And other than that, it really wasn't that bad. So let's go ahead and commit it and end the stream. And I'll go send you all to raid someone who's working on day 24. But good luck to people. I guess the top 100 have filled, but like there's still nowhere near the top 1,000. So yeah. Yep. I am glad that I did not even try to do day 23 tonight. I'll think about day 24 tonight. I'll do day 24 tomorrow instead. Maybe. We'll see. Day 23B complete solution. All right, that's now on GitHub in case you want to have a look at what I did. And with that, let's go ahead and say hi to someone. Let's go say hi to VWoo. Cheers, folks. See you tomorrow.